Data frames and tibbles are effectively the same thing. They are a way to represent two-dimensional data. So that is columns and rows, except tibbles are slightly more advanced in the way that they present that data, and they present it in a more easy to read way. And I'm going to show you that now. So I've got this CSV file called emptycars.csv, and I'm in the project teaching _R, which means that I don't need to set my working directory. So I can go straight in and say read.csv and give it emptycars.csv. If I run this, it outputs into the console, and it looks like it's outputted fine and it's read in fine. I'm then going to assign this to an object called raw, and this is popped up in the environment. You can see there's 32 rows and 12 columns, so that's fine. I can look at the class of this, and I can see that it's a data frame, and I can also do some summary statistics. So if I wanted to take the MPG, miles per gallon column, and take the mean of it, I get a value of 20.1. So that's fine. That's a data frame, standard base R. However, with a tibble, if I want to read in a CSV file and for it to import as a tibble instead of a data frame, I can use the read underscore CSV function, which comes from readr, which is in the collection of tidyverse packages. So I'm just going to load the tidyverse packages, and I'm going to say emptycars.csv. Now, I'm going to also assign this to an object called raw2, and when I do that, it actually gives me some information already. It says the 32 rows, 12 columns, which is great. It tells me that there are 2 character columns, model and gear. Gear I wasn't expecting to be a character column, so there's a potential issue there. And there's 10 numeric columns. So let's have a look at the data itself. So when I run this line, it outputs it as a tibble. So there's a few differences. Firstly, it only shows the first 10 rows, which makes it easier to read, and it says I can use this function if I want to see more than 10. It tells me that there's 32 rows and 12 columns, which is useful. Also, underneath each column name, you can see that it tells me the data type. So it tells me that model is a character, which is as expected. MPG is a double, which is just numeric. And then it says the gear is a character, and this should be the number of forward gears. So if this is a character, then there's been some issue, and that's because this data I have actually modified so that I've put a letter in here to emphasize the fact that it's good at detecting errors. And there's also the useful feature that it shows negative values in red, which is really useful, especially in this case, because I didn't expect this number of carburetors to have a negative value. So that tells me that that might be an error. So if we view this raw2 and we scroll down the gear column, I can see here is the error, this B value. There's also an NA in there. So the good thing about tibbles are that they present the data in a more easy to read way. And you can convert between tibbles and data frames using the as tibble. So I take the the data frame, and I can do as underscore tibble, and now it outputs it as a tibble. Likewise, I could do as dot data frame, and I could convert the raw 2 into a data frame. And notice you have to, it will print all of the rows as a data frame, which is often, if you've got a large data set, is not what you want. You just want to see a snippet of it. So tibbles and data frames are effectively the same. They present your, or they show your data in a two-dimensional way, rows and columns. Tibbles are slightly easier to work with. And that's especially true when you start working with the tidyverse set of packages. Then it's much easier to work with tibbles.